All right, so we've got problems that look like this. 9 to the 2x equal 27 to the x minus 1. Okay, so that's our problem. That's what it's going to look like. Now, way back when, earlier, like last week or maybe even the week before, we talked about rewriting them to have the same base, right? You guys remember doing that? Where they were the same bases, so then the exponents were the same. And it was a lot different because it was just saying like x equaled 2 or x equaled 3. That's not what's going to happen here. However, it's the same kind of principles in the fact that we're going to get them to be the same base. What base numbers can both 9 and 27 be written as? 3, right. 3 to the what gives you 9?
7.
Right. So here's what happens. It ends up being 3 squared to the 2x. What do you do when the exponents are written like that? Multiply them. What is 2 times 2x?
4x.
Good. Now I need to do the same thing on the other side. What number, or what can I write 27 as? 3 to the third. Good. So this ends up being 3 to the third to the x minus 1. When you've got a 3 and an x minus 1 like that up there, what do you do with the exponents again? Multiply them, and in that case, we're going to have to distribute, right? So I end up with equaling 3x minus 3. And that's the part right there that most people will mess up, is you will not distribute that 3 out like you should. Now are the bases the same? Yep. So if the bases are the same, then we can go ahead and put the exponents equal to each other. So over here, I've got 4x equals 3x minus 3. Solve for x. What would you do? Subtract 3x. So I get x equals negative 3.
Wait, what? How'd you get? Oh.
How did I get what, Markel?
3x minus 3.
How did I get this one?
Yeah.
Okay, just to go through that again. This number here is the same as 27. So then when I have a 3 right here and an x minus 1 there, they get multiplied. And when you do that, you distribute it to each piece.
All right.
Does that make sense? What do you think of that one? Not too bad? Okay. Now, that obviously is going to be one where you can write them as the same bases. However, now I'm going to give you ones where you are not going to be able to write it as the same base. 4x equals 11. Okay? There is no way, shape, or form that I can make a 4 make it look like an 11 or vice versa. I cannot make these the same base. No matter how hard I try, it ain't going to happen. But the thing that I want you to identify with that is the fact that your exponent is your variable. Okay, do you see where the exponent is, or the variable is at? It's not saying 4x equals 11. It's up in the exponent. It's saying 4 to the x equals 11. Now, how I do this, or what I do first, is I move all the pieces that are not exponents to the other side. So if I had an adding out here on this side over here or something, I would have to get rid of that. Okay? I need to move everything over. It's undoing the order of operations. So if I have an adding or subtracting, I move it. If I have a multiplying or dividing, I move it. Now it's time to get rid of exponents. How you do that is you use the laws that we had last week. Okay? So what I'm going to do is, if I do something to one side, I got to do it to the other. I'm going to log both sides. What I mean by that is I'm going to put a big log into each side. Okay? So the original problem was 4x equals 11. I'm logging both sides. Here's why I do that. Law number 3, the one that we dealt with some of the ones that you guys asked for on the homework assignment, is the exponent law. That means the exponent goes where? Yeah. I move this exponent now to the front. So it ends up looking like this. X log 4 equals log of 11. Now your job on this problem is to solve for x. So how would you get x by itself? Not add. Divide, because it's being multiplied, right? If there's no symbol understood right here, it's understood to be a multiplication. So therefore, I'm going to divide both sides by the log of 4. Now, here's what does not happen. Unlike most of your math that you've had so far. The logs themselves do not cancel out. And your answer is not 11/4. Okay? You actually have to physically now take your scientific calculator or graphing calculator and type in the log of 11 divided by the log of 4. And you will, yes, get decimals. Okay? And correct to so many decimal places, probably like 4. What's our answer? I can't hear you. Okay. In order to move the exponent out of the, or in order to move the x out of the exponent, you need to log both sides. Okay? That's how you do this. That's for the most part, that's the entire assignment where we're getting rid of it by logging both sides. So if I give you another one that looks like this, if I have 2 to the x equals 5, again, I know that there is no way, shape, or form I can make a 2 look like a 5 and vice versa. So how do I get the x out of the exponent?
Wait, what was the answer?
1.7 something something something. 1.7297. Okay, so what do I do to both sides in order to get the x out of the exponent? Log. Right. I log both sides. When I log both sides, what that does is then takes this x, and I'm able to now, using the laws, put that out in the front. Is everybody okay with that? Does that make sense? So then what ends up happening is you have x times the log of 2 equals the log of 5. And how do you solve for x? Divide by log 2 to each side, and I've got my answer. What is log of 5 divided by log of 2?
Are we going to do these where it's not base 10?
That's what we're getting it as. Right now up here, Markel, when we first started, it was 2 to the x. That's not base 10, that's base 2. Because it has a 2 as the base. So what we're trying to do is we're trying to use the logs in order to make them into base 10, so that way we can use the calculator to divide it out. All right, what did we get? 2.3219er. Okay, good. So far, so good? All right. Then, if I've got one that looks like this, for e negative 0.3x minus 7 equals 13. First and foremost, I need to make the exponent by itself, which it is not. That exponent is not by itself right now. Okay? This part right here needs to be all by its lonesome. It needs to be separated. So, go through the order of operations in reverse order. I get rid of adding and subtracting first. Is there an adding or subtracting I need to get rid of? Yeah, what is it, Fallon? Yeah, how do I move the negative 7? Yeah, I add 7 to both sides. What's 13 plus 7? 20. Very good, Fallon. All right. Now, from here, Liz, is there anything else that needs to move before I do some fancy footwork? No? Hey, Katie, what about you?
Maybe get rid of the 4.
Maybe get rid of the 4? I think that's a great option. Remember, the order of operations states in reverse order, add, subtract, then get rid of multiply and divide. So in that particular case, Liz, I do have a multiply there. So this needs to be divided by 4 to both pieces. So then I end up with e to the negative 0.3x equals 5. Now on the first two that we did, we dealt with logging both sides because we're dealing with numbered bases. This is the natural base e. Okay? So which log do we use for this one? Do we use regular log or do we use ln? We use ln in this case because we're dealing with e. Remember how I said natural base? What's ln stand for? Natural log. Or in Noah's case last week, the in button. Right? Okay? But we are going to ln both sides. And that's what we're going to do for this one. Because we have e in play, we're going to do the ln to both sides. And that's what's going to end up happening for this. Okay?
I apologize for interrupting you. Is hockey, we're going to do a standing ovation. Is boys hockey, do they rake them in a place like right now boys basketball's in first in state?
Yeah, the state poll were fifth.
Yes. Okay, do you know where the girls are?
They're either, I think they're fifth in the state right now too.
Okay, thanks.
Yep. Okay. So when we ln both sides like that, this ends up canceling each other out. Boom, 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 boom. Done. And the e and the ln are opposites of each other. That's what happens. So when I have the e in play, and if I ln both sides, boom, they are 100% opposites of each other. Like adding is to subtracting. Like when we got rid of the 7 up there, we got rid of it by adding the 7 over or subtracting the 7 over. So we've got negative 0.3x equals the ln of 5. How do you solve for x from here? Alyssa, what do you do? How do you solve for x? Divide by negative 0.3. Awesome.
What happened to the E?
Yep, when you ln both sides, Noah, the e's and the ln's cancel each other out. Much like adding cancels out subtracting and vice versa. Right? Or like squaring and square rooting.
Wait, so the L1 goes away too?
So the ln goes away because the ln and the e right here, see where I have it scribbled out? These cancel each other out right there. Okay? So now on your calculator, you're going to take the ln of 5, make sure you close that out, divided by negative 0.3. And what'd you get? I can't hear you.
Negative 5.3640.
Negative 5.3648. Okay. What, Markel?
Why is the ln still there? Did they cancel it?
Okay. Originally right here where you had the e, in order to get rid of e, you ln both sides. If you do something to one side, Markel, you got to do it to the other. Okay, so this ln and e cancel each other out, but there's nothing to cancel this out here. So it stays there. Remember when it comes to equation rules, what you do to one side, you got to do to the other. And it's always going to be like that. Does that make sense? Okay, good. Then, some of the ones that they're going to have for you is going to be set up like this, where it gives you log base 5, and then it has 4x minus 7 equals the log of base 5, x plus 5. Now the cool thing about this one actually goes really quick, only because of the fact that I want you to be aware of the base numbers. Okay? Casey, what are the base numbers for both of these? 5, right? They're both 5. And I don't know about you guys, but if something is supposed to be an equal sign and you've got bases and they're the same bases, shouldn't the parentheses be equal to then? If you've got an equal sign in play, shouldn't this be equal to this? Absolutely. So if you've got an equal sign, and especially if these two bases are the same numbers, then all you do for this is you put 4x minus 7 equals x plus 5. That's all you do. If your bases are the same, which you'll have some of them that are like that. If your bases are the same, you just put the parentheses equal to each other and we solve for x. Aaron, how do we do that now? Okay, we're going to add 7. Good. And what else could we do at the same time? Subtract x. Okay. So that way, now Aaron, what you did is you just told me one step. I'm trying to do 2 and 1. Save us a little bit of time. So what's 4x minus 1x?
3x.
3x. And on the other side, what's 5 plus 7? 12. And if I divide by 3 to both sides, x equals what? 4. Okay? Now, here's another part that you need to be careful about. If I make it equal to 4 like that, if you plug it back in, do you remember when we graphed logs the other day? What their domains were? What was the domain of the logs? What was the domain? It was from 0 to infinity. Unless we got it shifted, that was okay. But if you put it in there, what I'm saying is if you put 4 back into these equations and you get something that equals a negative number, can you have that? Remember, you can't remember the x's can't be negative in that respect, because if we go backwards like that, we're not graphing it there. So I don't remember if any of them show up like that, but in case they do, it might be a good thing to check it. Okay? If they're the same base, though, set the equal signs or set the parentheses equal to each other and go from there. Then, another type that they're going to have for you is going to be something like this, where it has the log of base 4, parentheses 5x minus 1 equals 3. Notice how there's only one log on the one side? Okay? If it's set up like this, what I would do is I would rewrite this as an exponential equation. So, what's the base number? 4. What would the exponent number be? The exponent number is right there. Remember, this one's the base. This one's the exponent. So in this particular case, I'm going to go 4 to the third equals, and then what am I going to have? Now I'm going to have the 5x minus 1. Okay, so what I've done is I've taken the log out, rewrote it as an exponential, and now I'm going to solve for x. First thing I need to know is I need to know what 4 to the third is. 64. That is a number that seems to continually repeat itself in these problems, does it not? I don't know about you guys, but I notice a pattern that they use that number over and over again. Then, how do I solve for x now?
What is that? Is that LN?
No, it's 64.
Oh.
Add 1. That's just a fancy 6. Sorry, Markel. 65 equals 5 to the x. What do I do to get rid of the x, or solve x? Divide by 5. And what's 65 divided by 5? 13. Okay? If it is one log on this side and a number on the other, I would do that. Okay? If it's one log, like if the log is all by itself here and there's just a number on that side, absolutely rewrite it as an exponential, solve for x. Okay? If that's the problem that they give you. And one more, and then I'll... Okay. This one happens to be in your assignment. I wanted to give you at least one of them. Okay. If this is the case, what would you do first? Subtract 3. Good. What's 21 minus 3? Okay, now what? Divide by 4. I know that 18 divided by 4 does not come out evenly, and that's okay. It doesn't have to. But I should get 9 halves, or 4.5, or 4.5, right? Is everybody okay with that? Now, something that we haven't talked about, and the reason why I wanted to do this one is because of this reason now. We did one earlier that was similar to this, but not exactly 100% like it. if I had E, I got rid of it by ln'ing both sides. If I have ln in play, how do I get rid of it? E it. I E both sides, right? So I'm going to E both sides. What that does, again, is the ln and the E cancel each other out. Markel, are you okay with that? Because you asked that earlier. It still stays over here, though, on this side. Okay? Because there's nothing to cancel it. So what that does is it gives me negative x equals e to the 9 halves. Which, again, that's what we have a calculator for. We can do that. Now, how do I solve for just x? Divide by negative 1. And then in your calculator, you're going to have e to the 9 halves, or 4.5, or 4.5, divided by negative 1. And when I get my answer, I get negative 90.0171 if I go to 4 decimal places. That's the last one that's in your assignment, by the way. Okay, so that was the last one that was in there. That's kind of the concept that you guys are going to be doing or solving them for. Remember the different pieces. There's a couple of them that are similar to what we did and so on. Some of them where you got to rewrite the same basis. Some of them where you're going to have to solve for ln. Some of them where you've got log on one side where I'd rewrite it as an exponential. Okay, everybody okay with that? Seemed okay anyway? All right, so on page 519 to 520, we've got 4 to 40 multiples of 4.